Hey, welcome to the Explainer. Today, we're going to talk about a really powerful programming pattern, one that can take your code from being rigid and fragile and turn it into something that's super flexible and robust. Seriously, this can be a game changer. I mean, just imagine for a second, what if you could swap out parts of your software as easily as snapping on a new Lego brick? Without having to tear down the entire structure just to make one little change. Well, that's exactly what we're aiming for. Let's dive in and see how we can get our code to be just as modular. All right, so first things first, let's look at a really common problem. We're going to use a simple data pipeline written in Python to see what I mean. Okay, so here's our code. We've got this data pipeline class. And if you look inside, you can see it does everything. It loads data from a CSV, it does some transformations, and then it exports that data to a JSON file. The key thing here is that all of this logic is baked right into the class itself. It's hard-coded. So you might be thinking, what's the big deal? What's the problem with this? Well, this approach, it's just brittle. Think about it. What if you want to read from a database instead of a CSV, or maybe export to a different format? You'd have to go in and start changing the class itself. And that makes it really hard to test in isolation, a pain to reuse anywhere else, and almost impossible to extend without breaking something. Basically, the code is totally rigid.
Okay, so that's the problem. Now, let's talk about the solution. And it all comes down to a really cool shift in thinking. It's called inversion of control.
And the key to making that happen is something called dependency injection. Instead of having a class build all of its own tools from scratch, we're going to do something different. We're just going to give it the tools it needs to do its job. We'll hand them over from the outside. And this right here perfectly illustrates that shift. Before, our data pipeline was building everything itself, the loader, the transformer, all of it. But after, we're just giving it those things when we create it. That's the inversion of control we were talking about. The responsibility for creating those parts, those dependencies, it moves from inside the class to the outside. And that one simple change, that's what gives us all this incredible flexibility. So, how do we actually do this in our code? Let's refactor that pipeline we saw earlier and see this principle in action. It's really a three-step process. First, we're going to pull all that logic, the loading, the transforming, the exporting, out into their own separate classes. We're separating the responsibilities. Step 2, we'll prep our data pipeline class to receive these new pieces by adding an initializer. And finally, step 3, we'll actually create instances of our new components and inject them, or pass them in from the outside. So after we've refactored, take a look at our main function. It's got a whole new job. It basically becomes the configurator or the assembler for our pipeline. This is the spot where we decide, okay, I want this loader and I want to use that transformer and I'll send the results to this exporter. We put all the pieces together here. And the beautiful part is, the pipeline class itself, it has no idea how any of those individual pieces actually work. It doesn't care. Okay, this is already way more flexible. But we can take it even further. We can make it even more powerful by adding a layer of abstraction. And in Python, we can do that with something called protocols. The power outlet analogy is perfect for this, right? As long as your plug has the right shape, the outlet doesn't care if it's a lamp or a laptop charger, it just provides power. A protocol works the same way. We can define a transformer protocol that just says, hey, whatever object you give me, it must have a .transform method. That's the contract. So the pipeline doesn't care about the object's specific class, only that it meets that contract. So let's look at an example. We'll start with the transformer called clean missing fields. We inject that into our pipeline, and everything runs perfectly. No problem. But now, what if we want to do a completely different kind of transformation? Say, one that removes my name from the data. Look at this. All we have to do is change one single line, the line where we create the transformer. We swap out clean missing fields for remove origin. We don't have to touch the pipeline code at all. And it just works. How cool is that? And this quote really nails it. The nice thing now is if you look at the data pipeline itself, it doesn't know anything about how it loads the data, how it transforms it, how it exports it. That's the really nice thing about dependency injection. This is the true power. The pipeline is completely decoupled. And as a huge bonus, this makes testing an absolute breeze. You can just inject fake mock objects to test your logic without needing a real database or a real file. Now, you can imagine that for really big, complex applications, managing all these dependencies by hand could get a little messy.
And that's where something called a DI container comes in.
So what is a DI container? Well, think of it like a central registry for all your application's components. It's a tool that automates the whole process of wiring up your app. You just tell it, hey, here are my components, and here's how they connect, and then it handles all the creation and injection for you. It can even manage how long those objects live, like should it create a new one every time or just reuse the same one over and over. And you'll see this pattern everywhere in modern software development. For example, popular web frameworks like FastAPI have dependency injection built right in. It makes it super easy to do things like inject a database session right into your API endpoints. It's really a cornerstone for building clean, maintainable, and testable systems. All right, let's bring this all together. We've seen what it is and how it works, but the big question is, when should you actually use this powerful pattern? So here's a quick cheat sheet. Is it a good fit? Absolutely. If you need testable business logic, or if you think you might need to swap implementations later, like going from local storage to cloud storage. It's great for complex things like machine learning pipelines or web frameworks. But is it maybe overkill sometimes? For sure. If you're just writing a small, simple script where the functionality isn't going to change, you probably don't need it. The key really is to use it where you know you're going to need that flexibility down the road. And here's the most important takeaway. In like 99% of cases, you do not need a big, complex framework to do this. That manual approach we showed at the beginning, where you just pass the dependencies in your main function, that is simple, it's elegant, and it is incredibly powerful. It's often all you need to start writing much cleaner, more flexible code. So I'll leave you with this final thought. Is your code a monologue where one piece is rigidly dictating everything? Or is it a flexible conversation? Because that's what dependency injection gives you. By decoupling your components, you turn your code from that rigid monologue into a dynamic conversation between all these interchangeable parts. Thanks for watching.